What up, your boy C. Rizzy coming at you with Unit 4, Lesson 7, Congruence in Overlapping Triangles. Our essential question is, how do I prove triangles are congruent to one another when they overlap? And our objective is to identify congruent overlapping triangles and to prove that two triangles are congruent using other congruent triangles. Our essential understanding. You can sometimes use the congruent corresponding parts of one pair of congruent triangles to prove another pair of triangles congruent. Overlapping triangles may have a common side or angle. You can simplify your work with overlapping triangles by separating and redrawing the triangles. So our goal today is to learn how to just separate the triangles so we can visualize them and then try to prove congruency. So here's a little picture from your textbook that just asks, what is the common angle in triangle ACD and triangle ECB? So what they did was they outlined triangle ACB or ACD and then redrew it over here. And then they went ahead and did the same thing with triangle ECB. And then redrew it over here. So then the question was, what is the common angle, meaning what angle do they share amongst them? And the common angle is C. So angle C in both of these triangles would be exactly the same. So here's our new question. What is the common side in triangle ABD and in triangle DCA? So the first thing I'm going to do is I'm just going to trace triangle ABD. And I'm just going to redraw it over here. So A, B, D, there's nothing special about it. I don't have to really mark any of the angles. I don't know if anything's congruent. And then I'm going to trace triangle DCA. DCA. And redraw it over here the same way. DCA. So the question is, what is the common side of the triangle? So you got to look at the two triangles that we just drew and say, okay, what's the similarity? And you can see the similarity is in side AD. So the common side is side AD. Okay, so here's a really long proof that we're going to work through. So given angle CAD is congruent to angle EAD, and angle C is congruent to angle E, I want to prove that BD is congruent to FD. Okay, so I'm going to first try by proving some sort of triangles are congruent here. So I've got a triangle, two triangles with two given angles. So what I'm going to do is I'm going to first separate these things. So I'm going to pull apart what is triangle ADC and pull apart what is triangle what happened there? Okay, I guess this came apart. And what is triangle AD? There we go. What is triangle ADE? Okay, and we were already marked that these angles were congruent to each other, and we marked these angles were congruent to each other. So I also know that AD is congruent to AD. There's a common side. So I know that these triangles are congruent to each other. So I'm going to use this knowledge that these two triangles are congruent to each other in hopes to figure out BD is congruent to FD. So what I'm going to do is I'm going to kind of just start a small proof here. Statements, reasons. So one is obviously everything that's given. Two, we were able to say that AD is congruent to AD because of reflexive property. reflex prop. So then I can say these triangles, we'll call it ADE, is congruent to triangle ADC by angle, side. So now once these are congruent to each other, I can just start rattling off pieces of congruent corresponding parts, like DC, I'm going to mark it here, DC is congruent to DE. DC is congruent to DE. And since I've already proven these triangles are congruent, that's just CPCTC. Now I've also already proven these angles down here were congruent to each other. C is congruent to E because that was given to me. Okay, so now I'm kind of focusing in over here because that's where BD and FD are part of. So what I'm actually going to do is I'm now going to move this over here. I'm going to relabel. This was B, C, D, F, and E. And we already said these were congruent to each other. And then we just proved DC was congruent to DE because of CPCTC. And now I've got two triangles again that I can probably prove their congruence if I can prove something right here in vertical angles. So now I know. So I hope you copied this down because I'm going to erase this and restart. So because I'm going to go to statement 6 or statement 5. So statement 5 is that angle BDC is congruent to angle FDE because they're vertical. And now I have two triangles here that are congruent to each other. Triangle BDC is congruent to triangle FDE by 6 angle side angle. And now we go back to what my proof statement was. I wanted to prove that BD was congruent to FD. And now I can, because now that I proved that these triangles are congruent, BD is congruent to FD by CPCTC. Again, because I just proved that their triangles were congruent, now BD is congruent to FD. Okay, so there's a lot of thinking, there's a lot of step in overlapping triangles, and it all works out if you can separate the triangles and just try to keep organized everything that's congruent to another and all the corresponding sides and all the common sides and angles that are congruent to each other. Otherwise, that's it for me.